So we'll just go ahead and get started with this. I don't have a whole lot to go over because probably the hardest part of this is when you see a problem like that. It's telling you where to start and how do you get to that structure that you see on the end. Because it says starting with benzene, how can you produce that structure in 2 steps? Or 3 steps if you want to count benzene as being number 1. Okay, so with that, as you're working on that paper, is that chart helpful? I think some people would say yes, some people might say no. Okay? Okay? And with that, we'll, like I said, we'll try to keep this short and get you on your way. But as a group, what does R mean?
Any number of halogens.
No. You said X. That's X.
You said R in one of the videos because I wrote that down.
Rats. Okay. So R is any alkyl group. And whether it's CH3, C2H5, C3H7. Okay, well, that's a big time mistake on my end. Okay. It's not meant to be that way, but yes, R is an alkyl group, and then X is your halogens. Did anyone else write it down that way? No? Okay. Try to keep the damage to a minimum then, if we want to call it that. So now what would X mean? X is your halogens, okay? And when you're reading that chart, okay, the very first thing you're going to want to do, all right, is this. We'll just make this up here as an example. Okay, so as we look at this, the first thing you're going to want to do, what are we starting with? Okay, we're starting with phenol. Okay, and the reason that's important is when this reacts, this halogen, with this metal halide, why is that so important, that OH group? Okay, and it's on your charts, that upper left-hand corner. Okay, one of the things we said, when something is on that ring, when that reacts, why is that important? Because it tells whatever it is that you are reacting that with where it will attach. Okay. How many products do we get? 1 or 2? It is 2. All right. Because what is that telling that chlorine to do? This is still going to be in the same spot. So where would 1 chlorine attach to? Okay. And what about over here? Right. Okay. Because as you are correctly saying, it's telling it that's where to go. Okay. Because it directs it in the ortho position and the para position. There's only one of these that's on the ring that would tell it to go 2 spots away. There's only one of those. And that is which one? That's a nitro group. That is where the only meta positioning director that's on there. Everything else is these two here. Whether it's in our group or, like I said, CH3, C2H5, and so on, C3H7, like we verbally said. All right. I think we can erase the rest of this too. All right. So if we're starting with benzene now, and I think part of the problem is this current situation that we're in and just the timing of it. There is another practice paper that we'll probably hand out next week, maybe on this end of the table. Maybe we're trying to go too fast and because of our current situation with dividers, masks, people here, there, people having to go home for various reasons because of, again, this current state that we're in. Maybe the expectations are too high. Maybe yes, maybe no. But it's not intended that way. And then being gone for that state cross-country meet, that probably didn't help either. Okay. But let's try to make the best of this situation. So, starting with benzene. So here's, if you want to say step one, it says 2 steps. Maybe you'd rather say 3 if this is step 1. So what we have to do is get a methyl group attached on there first. Okay? So what that means is what we had just said, any alkyl group, which a methyl group is, you would want to find somewhere on your chart where you would find that, R and X. Where on your chart does it show where you can attach R and X? Like, if you're pointing to it about on a clock, where would that be? Okay, so at about 9 o'clock, okay? And I don't have a chart in front of me, but when you look at that, we can't just take this CH2 Br and just attach it to the ring in one step. It just doesn't work that way. It has to be done in 2. The reason for that is because of the stability of this ring. All right, so we're looking for this. All right? So do you think we would write that? That is incorrect. It's close, but here again, if you are not comfortable with the molecular formula, you can always do what instead? The structural formula. So if you can understand that this is incorrect, you're well on your way. You're about a little over halfway to really getting a good understanding of this. Is anyone confused on why this is incorrect? Because if we don't address that, then we really can't fix it. Okay? Because how many bonds does carbon want and or need? Okay? So if we address that carbon, and we've got 2 hydrogens, and then we've got that 1 bromine, where's that guy? Okay? That's why you would not want to, we said it's close, then you would have 5 bonds. You went 1 too far. Okay? So if you take that, we said CH4Br, okay? 1, 2, 3 hydrogens. There's our bromine. We can't just do that. Then it's got 5 bonds. Okay. So if it's not CH2Br, it's going to be CH3Br. And what that means then, there's your 3 hydrogens. There's your bromine. Okay. So we're taking this, and we want to get just the R to attach on that. And we said it's about on 9 o'clock on your chart, okay? So what else do we have to attach onto this? Or make it react. What does it tell you? Okay? So we can just pick any, even that, but you probably should stick with what you're reacting that with. I think that would make the most sense. Okay? So what does this tell you on that chart now? So when this reacts, then, okay, what is going to happen to this molecule? It's going to break apart right here. And what's that methyl group going to do? Yeah, it's going to attach. This is one way of creating toluene. Okay. Now, you can write it like that. What else could you do? Again, that's a molecular formula. Maybe you would be more comfortable with what instead? The structural formula. Okay, now we've got the same thing. We still have toluene. Now, this is where, I don't know, is it kind of like Candyland where you're on that board game where if you draw this card, you go shooting one way, or if you draw a different card, you go shooting the other way? Does that maybe sound accurate? No one's played Candyland in here? It's been a long time for me, but probably got stuck in the swamp every time. I don't know. But now, can anyone tell me how are we going to get that bromine to attach onto here? Okay. We heard two different answers. One said heat. Oh, okay. Now, the reason we say that, okay, now we've got our toluene on here. Now we're still at 9 o'clock. This is where that chart diverts in two different ways because one, you're using a catalyst. The other one, one, you're using a metal catalyst. The other one, like you had just said less than a minute ago, was, okay, if we do this, all right, now we're going to add that bromine on there. And we'll just keep it consistent. What happens to this if we use a metal catalyst according to your chart? Are we going from this? Are we going to get that? Your chart tells you no. But you can do it providing you change that to rather a metal catalyst to what you just said a minute ago. Heat. So if we change this to heat, what that is going to direct that to do is attach onto here instead. And that would be, if you can draw these better than myself. Okay, let's try that again. And again, I can't stress that enough. I've seen that over and over and over again where students like to make the toluene, write CH3 on there, and then when we add this bromine, we end up writing CH3Br. And it's a minor mistake, but it's one that we want to make sure that we correct before you move on to the next step, which is at Oral Roberts or SDSU or USD or I almost said Lake Area Tech. That's not right. Minnesota West. Okay, and I don't know if I've hit the. I know that position, but probably not so much there. But the rest of you, is it still up in the air what you want to do? Maybe yes, maybe no. Okay. How many of you think this is difficult? Okay, I would tend to agree. And are we going too fast? Or is it just because we don't have the instructional time either? Okay, all right. So why don't you look at that paper? Can we close the books on this? And I'm hoping, how many of you, turning back the clocks where it was 3 years when you're a freshman, or last year when you're in general chemistry and you had to deal with that table? I'm willing to bet that when you're a freshman looking at that slide rule for the first time and utilizing the periodic table, I'm never going to get this. I don't know if you thought that way. Yes, no. But you accomplished that, okay? And hopefully there's no reason that you would not accomplish this. Okay? And I guess, I don't know, I've always, and maybe you've heard this before, I hate saying, well, if you don't know what to do, you've got the book. I mean, it's kind of like in basketball. If you don't know what to do with it, you're never wrong by driving to the hoop. At least I don't think you are. If you don't know where to pass it, where to go to the basket, okay? But in this case, if you feel maybe you'd be better off, there's a whole set of textbooks back there too, but I'm afraid that you get lost in the wording there. It's not that you can't understand it. It's just that's why we want to work on this together. And that was, I'm sorry, what number? Okay, need to. All right, you're going to have to tell me what number 16 says. Is it a word? It's not a word problem. That's the last two. Oh, okay. Then you're reacting that with propyl chloride. Okay. So what is propyl, that prefix? 3. Okay. And maybe we'll just write it in the structural form. Okay. And propyl chloride. Okay. So where do you, I think that makes the most sense, where would you want that chlorine? Well, it doesn't say 2-propyl chloride, it just says propyl chloride. So here you could say C3H6, H7Cl. Okay? 3 carbons, we got 3, 5, 7 hydrogens and 1 chlorine. Okay, so what does it say after this? It makes a difference on what you're reacting that with. Okay? Now, as you look at this, this is another example of R. Okay, all of this, because it's an alkyl group and a halogen, R and X. So, what do you think? Will you get 1 or 2 products according to that chart that you have? And maybe you said, and I just didn't hear it, I don't know. Okay? And you would be correct because, but why are you right though? Okay, that's one way. Is there anything on here? No, because if there was something on here, then chances are you would get how many instead? Then you would get 2. So that's why we want to say, look at where you're starting in the middle of that entire chart. Okay? Then we've got R and X. So how is that going to attach on there? How many hydrogens would we get? How many hydrogens? Are you sure? That's right. Now, that comes with practice and experience because it would just be human nature to look at this and say, oh, C3H7Cl. So if we do this, that would be incorrect because one of these is a carbon to hydrogen bond. We'll just say it's this one. But we got to get that attached to the ring. So this is no longer a carbon to hydrogen bond. This is a carbon to carbon bond. And that's why it goes from 7 down to 6. Okay, you have to.
Like the question we just did, we didn't put the bromine on there, so how do we put the chlorine on there right now?
Oh, you are correct. Yeah, he's not on there. But then, yes, that's still C3H6. Okay? Yeah, you can put that on there. And that's not, that one disappeared, so that's C3H7. There we go. Okay. We're not going to have to do any exorcisms on anybody because our heads are spinning around in a complete circle. Has one ever seen The Exorcist? I haven't either, but I thought in that movie, wasn't there someone who turns their head all the way around in 360 degrees? That'd be pretty disturbing, wouldn't it? Yeah.
Okay, so then there is 7 hydrogens?
Yes. Because I had that chlorine on there, and for some reason I thought that had to stay on there. Yep.
Are you? Oh, straight up.
Okay. Is that like number 20? Did anyone on Friday, because we did record something Thursday night, but the sound was awful, is what I've been told. Okay, because I didn't have the microphone. I didn't even think to bring it home. I thought I would do that, and I thought, well, if I just stand right in front of the computer, that'll pick up the sound. That didn't happen, huh? Obviously not, or else you would have said so. All right, can we erase this then? So what does 19 say?
Illustrate a mechanism for the products of ortho. Yeah, it says bromo, but bromo, toluene, and parabromo.
Okay, so that's what we're looking for. That's what we want to create. So if we're beginning with benzene, the first thing we need to do is get that methyl group on there. And that will not do it. CH3. This will not do it either. So at 9 o'clock, well, 10 after 9 now. It's not 9 o'clock, it's 10 after. Because we need to get that toluene on there first, or that methyl group. Okay? Because CH3 is what type of group? It's an alkyl group. So you have to, there's a different way you can attach it on there too. You don't even have to use this. You could do something else if you so chose. But the simplest way is to do this R and X. You got this alkyl group, and then the X is what type of element? It's a halogen. Okay? So, go ahead and pick it. You don't even have to use bromine. You can if you wanted to. Okay? Okay. So now when this reacts, this splits apart. And what's going to attach on there? Of course, now we're halfway there because what's that methyl group going to do, of course? Give us toluene. Okay? So let's just go ahead and put him right up here. And what type of director is an alkyl group? And, right. So now that we've got this, now we see what we need to get, those two. Okay. So what are we going to add to that now? More bromine. Okay. And this is very stable. So what else would you have to have as a catalyst? You got many choices as far as a metal halide, but don't choose heat, because heat's going to do something altogether different. Okay. So what do you think you would put underneath that arrow? Same thing. You even put this here. Some more nickel bromide. You'd be just fine. Then you can wrap that up. Today being Wednesday, let's work on these for one more day. And then let's have that naming portion on, are you going that way to Selby? 1, yes. 2, yes. Just you two? Don't you all do stats though? Oh. Did you two draw the short end of the stick or something, or what? Oh, okay. All right, let's do this. I'm going to write this down, or else I'm going to verbally say it, and then I'm not going to remember. Okay. Let's do this. Okay. And then tomorrow, or no, excuse me, Friday, we will do this. Assign worksheet 5, chapter 4. Do, yay, we're up to November. We'll say 5. Because I know Tuesday is November 3rd, that's the general election, so the 5th would be on Thursday. Because some of you, well, you don't know what, oh, we play here Tuesday. Right. Okay. You just don't know. Well, you probably know who. And whether you know or don't know, it shouldn't matter. Reason I say whether it's a tough opponent or an easy one, if you think so, you want to come out with being on fire. All right, so I got that wrote up on the board. Tomorrow we'll wrap these up, okay? Get these turned in on Friday, and then Friday we'll sign the last portion of this. Does that make sense? Okay. Yes, I think probably a good idea. Take a mental break, just on account of even with this, we're up to 32 minutes. So hopefully at home wrote this down so we can proceed forward. We'll catch up to you next time.